All right, what's up, guys? In this video, we're going to pick up with some calculus here, and we're going to evaluate an integral here using the method of partial fractions. So we're asked to evaluate the integral x squared plus 4 over 3x to the third plus 4x squared minus 4x dx. So basically, partial fractions is used to integrate rational functions where simple use substitutions just won't work. And a couple of things to keep in mind about partial fractions. In order to use the method of partial fractions, you need to be dealing with a proper fraction, which is if I have a p of x over q of x, remember that p of x needs to have a degree that's strictly less than that of the denominator. It can't be greater than, can't be equal to, it needs to be less than. If not, then you can use polynomial long division in certain cases to reduce the degree, or partial fractions can't be used. So keep that in mind. And basically what you do for partial fractions is we want to begin by factoring the denominator. And the whole process of partial fraction decomposition or what have you, it seems kind of stupid, seems kind of a bit of a drawn out long method, but in actuality, it's making the integral a lot easier. It's just that some integrals, as we all know, are just going to be hard to deal with, and that's just kind of the way it is. So we'll begin by factoring this denominator here, because we're going to want to split this up here. So the best thing I would probably do is just begin by factoring out an x. And then if I factor out an x, well, then that means that I'll have 3x squared plus 4x minus 4, which I can factor that as 3x, I think it's going to be 3x minus 2 times x plus 2. So this would be x times 3x minus 2 multiplied by x plus 2. Also, make sure for partial fractions, this is going to be one of the integration techniques that you're going to learn that is going to require that you remember all of your algebraic stuff, such as factoring and foiling and all that good stuff, expanding. So go back and review your algebra and all that kind of stuff, because you'll need that here. And you've seen partial fractions before, even though you may not remember it, but it just takes a little bit of practice here. So give it a shot. Don't give up. So we'll take our x squared plus 4, and we've just factored our denominator here, so it's just going to be x times 3 minus x squared multiplied by x plus 2. And again, you can check whether or not I factor that correctly by simply foiling that back out and distributing the x. You should get that back out. You can check me on that, but I believe that's correct. So remember what we have. We have our a over x. We have our unknown, or our unknown constant b, all over 3x minus 2. And then that's going to be plus c all over x plus 2. And remember what you do is we multiply both sides by this denominator over here, which is x times 3x plus 2 times x plus 2. So we'll begin by doing that. And if we do that, we obviously get x squared plus 4, because all of those will cancel out. And then it looks like we'll get a times 3x minus 2 multiplied by x plus 2. And this looks like we'll get b times x plus 2. And then it looks like we'll get plus c times x times 3x minus 2. Okay, so what you do next is you need to find the values of these unknown constants a, b, and c. Now, there's two ways you can go about doing it. You can do it by substituting in some values of x or whatever variable is being used. Won't always be x sometimes, depending on the integral, and trying to solve for the constants that way. Or the long, drawn out way that most people don't like doing it, but it has to be done in certain cases, is you'll need equate coefficients to solve the system. So just be prepared for that. Just simply substituting in values of x to solve for the unknowns isn't going to work every time. So just be prepared to do it the other way. And I'll post a video where we need to equate coefficients and stuff like that, maybe for another integral, maybe one that requires that. In this particular case, we can just plug in some values of x, see if we can solve for those unknowns. Okay, so why don't we start by trying to solve for a. So what we're looking to do is we're looking to find a value of x that we can substitute in, that we can end up basically canceling out the two other unknowns, which would be B and C in this case, since we're solving for A. Well, notice that this B here is being multiplied by X. This C is also being multiplied by X. I know that 0 times anything is 0. So if we let X equal 0, we know that that will cancel out B and C and isolate A. Now, what you'll need to do is you need to make sure you're plugging in a 0 for every place you see an X. Okay. So this may not make very much sense now as we're looking at it, but let's just see how it works. So it'll be 0 squared plus 4, and then we'll have A 3 times 0 minus 2 multiplied by 0 plus 2. And notice how I'm subbing in a 0 for every place I see an X. Then I'll get B times 0 plus 2 plus C times 0 plus 3 times 0 minus 2. And hopefully you see that the C goes away, the B also goes away. And then over here, we're just simply left with 4 is equal to, it looks like we'll get negative 4A, which means that A here is going to be equal to negative 1. So that's the value of the first unknown. So this is the easy way to do it, by plugging in some values. Won't work this way all the time. This is the funnest way to do it. The other way is not so fun. But we'll do another example. All right, let's try to solve for B now. So same principle here. Let's determine the next value that we can sub in here. Well, I mean, if we let, let's say, for example, if we let X equal, let's say we let X equal 2 over 3, well, then that would work, because then that would be 3 times 2 over 3 minus 2 times 2 over 3 plus 2. And then, yeah, it allows us to cancel out both A and C if we want to solve for B. So let's try to let X equal, let's try 2 over 3. And what value you want to let X equal will depend on the situation. So you kind of got to do a little bit of thinking. By the way, this is one that's a little bit more involved. So you may want to try one that's a little bit more simple for partial fractions first, before maybe trying one that's a little bit more involved. So just try a little easy one first. So we'll substitute in 2 over 3 for every place we see an X. So that'd be 2 over 3 squared plus 4. And be prepared to have a lot of paper for partial fractions, because it's a rather long technique of integrating. And I'm just going to plug in, I know that the 2 over 3 is positive, but I'm just going to put it in parentheses anyway, just to kind of make sure you don't get lost. So it looks like we'll have B times 2 over 3, and then we get 2 over 3, looks like we'll get plus 2. I did it over there, so I'll do it over here too. And then it looks like we'll get plus C times 2 over 3. I'm trying to write it so I can save room. Then it looks like we'll have 3 times 2 over 3 minus 2. And as you can see here, A will cancel out, and so will C. And now we just got to simplify everything else. Okay, so this would be basically 4 over 9 plus 4. And notice how I'm using my calculator as well, just to make sure that I'm getting the correct answer. So yes, that's going to be 40 over 9. Just wanted to make sure. And over here, well, it looks like we're going to get, looks like we're going to get 16B. Okay, we can simplify this down to, let's see, we can multiply both sides by 9, and then we could divide both sides by 16, and you can also plug this in a calculator. So it looks like B here is going to be 5 over 2, but again, I'm going to check my calculator as well. Make sure you're doing this. Again, passing a math quiz or test can come down to literally just a couple of points. So don't be afraid to just plug it in there and make sure your arithmetic is correct. Everybody's a human. Yes, I believe that's going to be correct. I'm going to check it anyway. Yes, that's correct. Okay, so now we got the value of B. Okay, that takes care of that. Now we'll need to find the value of the last unknown, or I call it unknown constant. Sorry, my fingers aren't big enough for to get the paper. Sorry. Just in case we need some more, we'll keep it over there. All right, so now I need to see what value we can let x equal that we can solve for c. So again, this requires a little bit of investigation. Okay, well, let's say we let x equal, let's say we let it equal -2. Well, if we let it equal -2, we subbed in a part for that, so that'd be, yep, that would get rid of, that would get rid of a. That would also get rid of b if we let x equal -2, and we plug it in for x. So yeah, let's let x equal -2, and that should work. So let's plug that in there. So every place I see an x, I'm going to plug it in there. Notice how I'm using parentheses for positive numbers. Okay, so it looks like we'll get a. We got 3, use parentheses, -2, -2. Sorry, I'm writing those small. I'm trying to make sure that we have enough room. And the reason why I said -2 is because -2 plus 2 is 0. And we know we'll be essentially multiplying by 0, which will get rid of the a. So that's the reason why I chose -2 if you weren't able to see. And it just so turns out that it also works that way for b as well. So it would be b times -2 plus 2. Looks like we'll have c, plug in a -2. We got 3 times -2 minus 2. So hopefully you see that those will go away. And here it looks like we're going to get, 8 is equal to, looks like 16c, which means that c is equal to 1/2. So that's the value of c. All right, so we're almost done. Again, try an easier one maybe on the first try. I don't think this is really hard, it's just lengthy. All right, so basically the whole idea for the partial fraction is we took an integral that we didn't know how to do, which was x squared plus 4, all over, what was it? It was 3x cubed minus 4x squared minus 4x, all integrated with respect to x. Basically what we did is we took the integral and converted it into something that we do integrate now, or can integrate. So remember how we had the unknown constants a, b, and c on top? Well, all we got to do is plug in those values and we'll integrate it. So that means that now this integral becomes the integral, and I'll put parentheses. Looks like we'll get -1 over x. No, I'll do it this. I was going to use the sum and difference rule, but I'll just leave it alone. -1 over x plus, let's see, we got 5 over 2 all over 3x minus 2. And then it was another plus. It's actually just going to be the sum rule for integrals. That could be 1/2 over x plus 2. And that's integrated with respect to x. I don't like the way I wrote that, so let me rewrite it. So this is really just the integral of -1 over x integrated with respect to x, plus the integral of 5 over 2 all over 3x minus 2. Integrated with respect to x, and then it looked like will be plus the integral of 1/2 x plus 2 all integrated with respect to x. Now obviously all of these are just natural logarithms, so this would be -ln absolute value of x plus, well, 5 over 2 is a constant, can be pulled out. So that would leave us with 1 over 3x minus 2, which we know will be 1/3 times ln absolute value of x minus 2, but we'd have to multiply by 5 over 2. So that means that this would be plus 5 over 6 ln absolute value of 3x minus 2. And then this one obviously is plus 1/2 ln absolute value of x minus 2. Now, make sure that you can do these types of integrals, stuff like 1 over x, dx, and whatnot, because not all, but the vast majority of these partial fraction integrals will yield to these natural logarithm integrals. So make sure you know how to compute those, because these partial fractions seems to always yield integrals with the natural logarithm. So make sure you know how to deal with those. So all we have to do to finish this is just tackle on a plus c, and that'll be our answer. So our final answer for this integral using the method of partial fractions, final answer, we're asked to integrate, what was the integral? It was x squared plus 4 all over 3x cubed plus 4x squared minus 4x, and we integrated that with respect to x. So our answer here looks like we're going to get negative ln absolute value of x plus 5 over 6 ln absolute value of 3x minus 2 plus 1/2 ln absolute value of x minus 2. And we need to tackle on a plus c. That would be the answer. Okay. So seems like a long, boring, drawn out process of how to break an integral up, but it has to be done that way because all integrals can't be evaluated with a substitution or by parts or whatever, or trig substitution or something like that. So that's how you do it. So let me know if you got any questions about that. I'll be more than happy to address it. So hopefully that made sense. All right, y'all take care, and I'll see y'all next time.